Oye, this video is designed to go with our A series scenarios. We're going to jump right in, but the goal on this is we're going to have kind of a hodgepodge of different things. You'll probably see some overlap with individual videos that we have kind of broadly for things like access times and adjusting orbits, but this video is designed to go specifically with our A series so that we can kind of put all the things that you would fundamentally need together in kind of a one-stop place, and specifically making reference to these scenarios. So taking a look at it, the first one that we've got listed up here is actually our very first scenario in the A series, where we're trying to maximize contact with a target in the state of Arizona. Now, this particular target is actually on top of a mountain and has very little when it comes to what we would call constraints. In other words, it's very easy to access this. We've got a satellite in its default orbit, which we'll get back to here in just a moment. But one of the first things that we're going to need, and I want to bring up so that we can take a look at it, is in order for us to actually analyze, to try and figure out if we've got a good solution or not, we need to take a look at our mission briefing. Now, I'm not going to read through the whole thing. Hopefully, you'll have a link to our mission briefing for A1A or 1A1, wrong order, or 1A2 or 1A3. Those are our current A series ones. They get a little bit more complicated as you go through. The important thing that I want to bring up here is on our scoring, we receive 2 points for every hour of access between our satellite, ISAT, and the ground station at Kitt Peak, KPNO, during our mission period. So, in order to tell if we've got a good orbit or not, we need to know how much contact time there is between our satellite and our ground station. Now, this is a very, very important thing that you'll need to do on quite a few of our scenarios and beyond, is to check the access times. In order to do that, there are a couple ways to do it. First off, over here in the object browser, we've got the overall scenario here that I could click on. I've got the ground station here, KPNO, but the main thing that I want is contact time between the satellite and KPNO. Now, I could actually click on either of those, but I'm going to focus on the satellite. In the A series, we only have one target, but as you go forward, we might have the satellite trying to contact more than one thing. Now, we'll emphasize some of that as we go through, but my favorite way of accessing the access times is to left-click on the satellite. It'll be blue outlined there. If you click again, it will actually switch where you can rename it. I wouldn't recommend that. If that happens, just left click off of it and it'll go away from the flashy rename. And then you can right click. Hopefully you're using a mouse. If not, there are some other techniques that I'll show you on this, but having a mouse for this is actually probably going to be pretty useful. After you right click, we've got a bunch of options. One thing I'm going to highlight is properties, the first one there. We're going to come back to that in just a minute. But the main one that we want is access. So this is one place where we can get the information we're looking for. Click on the satellite or the other object, the site, for instance. Right-click on it and go to access. Now, that will take us to this window. I'm going to close it real quick. Another way that we could do that is we can actually go up to analysis up here at the top, do the drop down, and click access here. Gets us the same thing, but it can get a little bit trickier with that. I like going to the object in the object browser, right-clicking, and go to access. Now, this is a preview for things to come, but I do want to draw your attention. When we bring up the access window, it says access for ISAT. That's our satellite. So it's basically saying, okay, that's the thing that we're checking when it can talk to other stuff or when it can see other stuff. We want to see when the satellite can see the ground station. Or in this case, we could also see when the ground station could see the satellite. It's all going to depend on how you want to approach your problem. On the upside for this one and any in the A series, you won't really have to worry about that distinction. If for whatever reason you bring up the access screen and it's looking for the access for an object you don't want, you can just come here to select object, and it will give you a listing of all the objects in the scenario. But I do want the satellite, so I'm going to highlight that and click OK. Now down here, I've got KPNO. If I had multiple sites, then there'd be even more filled in. But right now, all I have is this one, so I can click on it to select it and click Compute. Now the moment I click Compute, if you notice over here, we'll talk more about it later, but our two-dimensional graphics where we can kind of see the Earth and a line for our satellite on it, suddenly there's a blue half circle that showed up. Now, one thing I can do is I can delete all of those axes, and we see the circle goes away. But I can bring all that information back, which I actually want. So I'm going to hit compute, and that circle reappears. We're going to talk about that circle here in a little bit. But first, we need to actually look at our access report. That's what we're building towards. So we've got KPNO set. We've clicked compute, so we've got our access. I just need to bring up the report. Now down here in this window, it says reports, access, AER, and link budget, though link budget is not lit up. You'll see that in a much later video. But the main thing that we want is access report, or reports access. You can also do the graph, but the reports are going to give you the numbers you're looking for. In the off chance that you cannot see this, we have had some computers that are at lower resolution than the computer I'm using. If you can't see this, if, say, the screen is kind of cut off around here, come up to the top here, not the red X, but right next to it, there's a square. It says maximize. If you click that, it makes it go big, and then if you're on a low-resolution computer, there's a scroll bar that you can scroll down and find reports access. So, to make it go small again, you don't use this X up here on the very right. You use the two little windows, and it pops it back out, making it not as big as it possibly can be. On my computer, the resolution is actually set a bit higher, so I haven't had that problem. But I want to make certain that you're prepared for that, because depending on what computer you're using, it may not have the graphics processor that my laptop does. All right. Finally, after all that buildup, we've got here reports access. I can click on this, and now I have my access report. This is ISAT, my satellite ISAT, to facility KPNO. Doesn't hurt to double check that it's giving you the right thing. This is telling me that this is access whenever ISAT can see KPNO, which is what I want. Now I can look over here, and I've got access numbers that go all the way down. During our 2-week period from 10th of June 2024 to 24th of June 2024, we have almost 90 different contacts. And we also have the timestamps when they begin the contact and when they end the contact for each of those axes. Now, that would be a lot of math for us to go through. Luckily, this report actually has one more column. We'll just have to scroll over to it. And it says duration. And it says in hours. Now, it may not necessarily always say hours. If it's in a time unit that you don't want or you wouldn't prefer, maybe I'd rather have this in minutes, you can right-click on hour and go down to report units. And you can actually change it to say minute or seconds, whichever you want. You can also click set as default and then hit apply to actually make that take effect. Now that being said, this one is by default set for duration and hours, which is what we're looking for. It'll be the easiest to turn into our score. Down at the very bottom, beneath all the individual axes, we've got global statistics. The smallest duration, minimum duration, was access number 46, and it ran from this time to that time, and it was only 0.031 hours. My maximum duration, the biggest, was access number 74, happened on these times, and it was 0.225, almost a quarter of an hour. The mean duration, in other words, the average contact time, is 0.190 hours, so about 1/5 of an hour, maybe about 12 minutes or so. But the most important one that we're looking for down here is our total duration. Total duration, this is probably going to be the key number that you're going to be looking for a lot, but not necessarily always. We've got 16.907 right now. So that equates to, that's a little shy of 17. So I get 2 points for every hour. I have almost 17 hours. So right now I'm looking at a score of about 34. Not bad, but not great. Okay, this is how you can actually get the information you need to check access times, which is going to be important for almost all the scenarios that you need to do. That's why I wanted to spend a little bit of extra time going through broader details on this in case you don't get around to watching the other prep videos. But this one is where we can actually find out how good of a solution we have. Well, that's great, but 34 points doesn't sound that great. I need to try and up that some. Well, that means I'm going to need to change my orbit, which is the next part that we're going to take a look at. This will also be common, especially when you're using STK. May not necessarily be in every scenario, but it will be in most. I'm looking to change the orbital parameters of ISAT. Oops, I double-clicked on the world and it gave me the latitude and longitude of where I clicked. So just as a heads up, it does that. Okay, what I need to do is I need to change the settings on our satellite. Now, one thing that I'm going to bring up is always keep track of what your limitations are in this. I believe I went through, and in my briefings, we've got constraints where it says, hey, we can't have an apogee or perigee less than 200 kilometers or greater than 1,500 kilometers, and for anything else, we're actually completely open. As you go forward and learn more about the limitations of space missions, you may find that you're limited on things like inclinations, or you may even have a pre-described orbit. But on the A series, we've mostly left it open so that we've got a nice way that we don't have to worry about a lot of fine details. Okay, so how do we change the orbit? Okay, well, that's for the satellite. So I'm going to come back over here to the object browser, right-click on it, and I'm going to go back to Properties. Now, I want to talk a little bit about the Properties menu because this is, again, kind of a focused one and the first time where I can give you some warnings about how to make certain that you can solve the scenario appropriately. The first thing is basic, and we've got orbits here. Okay, great. That's exactly what we're looking for. We've got a bunch of our parameters back over here: apogee altitude, perigee altitude, inclination, argument of perigee, RAN, and true anomaly. These are the ones that we're usually able to adjust. I'm not going to say as much as we want. As we mentioned a moment ago, there are some limitations. I can't just make the apogee 6,000 kilometers, as much fun as that might be. My scenario is only going to be counting solutions that max out at 1,500 kilometers. That's effectively as high as we'll be able to get the satellite to go. But there are a few things that I want to bring up real quick, especially if you are using a mouse. First off, I want to warn you about the propagator. Now, propagator is kind of a complex thing. STK is incredibly powerful. I'm going to do the drop down on the propagator. The default when you add something new is, for the satellites anyway, is a two-body propagator. It's kind of a simplified one. Most of the scenarios that we work with are going to be J2 perturbation. And take note of whatever the propagator is and make certain that you don't change that by accident. We have gotten reports back of people trying to solve in some of the competitions and accidentally changing the propagator. We'll talk a little bit more about how that might happen in just a moment, but one of the ways that I know that it might accidentally happen is if you're using a mouse with a mouse wheel. Now, I'm not going to do it with a propagator because sometimes that causes my computer to freak out because it's got a lot of calculations that it needs to do. But I'm going to go over to apogee altitude. Now, that's one way that we can represent the first two parameters. Apogee altitude and perigee altitude are our preferred way of working with the orbital size and shape is how I've described it in the general videos. The classical is to use the semi-major axis and the eccentricity. Now, those are a little bit harder, and unless you're used to them and mathematically what they need, they're not as straightforward and easy to imagine. So we fully recommend that you use the apogee altitude and perigee altitude when you're doing your mission design. But when you do submissions, you might have to switch them back. Back to the mouse wheel, now that we've introduced that. If I go over this eccentricity, I'm not even going to click on it. So I won't left click, I won't right click, I won't do anything. But if I accidentally scroll my mouse wheel, oh, now it says perigee radius. Or if I scroll it up instead, or sorry, back down, now it's back to perigee altitude. I can actually accidentally change any of these boxes if I'm just over them with the mouse wheel. I don't even have to click in them. So that's one that you want to be careful of if you are using a mouse and the mouse wheel. Again, on computers that have different resolutions, you may actually have a bar that you have to scroll up and down. As you go down, be careful you don't accidentally change anything. If you change the propagator, it will completely change what the numbers are that are kicking out. In other words, you won't actually be able to rely on the numbers in the scenario anymore. That's why I wanted to mention it. In fact, I know one of them, HPOP, was one that we used that I think actually calculates things including air resistance. Some of these are actually going to go in and take into account relativistic effects, where there's time dilation depending on how deep in the gravity well is the technical term it is. We're not going to unpack all of that, but in short, all of these different selectors on the propagators allow us to either simplify the calculations, two bodies probably about as simple as they get, and not to say that as you go down the list they're guaranteed to get more complex, but each of them incorporate stuff that might be specific to a given mission. Be very careful on the propagator. Make certain you don't accidentally change that. We can go through here and we can change all of these things, but while we're talking about the propagator, I do want to bring up, I'm going to click cancel. There is one other thing that is apparently pretty popular, but I haven't used it myself, and I do not recommend my cadets to actually use it. If I go over to satellite, I have something called an orbit wizard. Now, in here, you can actually do some sliders and do some other stuff, but I believe this has been tracked down to be one of the issues that it may inadvertently change your propagator if not used correctly. In either case, it's not my preferred way of working with it, so I'm going to leave it to you if you want to explore that and work with it. I'm going to go back to my satellite, right-click, and go to Properties. All right, now that we've talked through the important things that you need to be careful of when you're making your adjustments, now I'm going to go through and actually make some adjustments. I'll tell you what, one thing that I think might help is if I get my satellite up higher. So I'm going to bring it up to an apogee of 1,000 kilometers, and why don't I go ahead and keep it a circular orbit and bring my perigee up to 1,000 kilometers. Now hopefully this video will become dated very soon, but there's been an error that's stuck around for the last couple of versions of STK. It's not a huge deal, but as you update your apogee and perigee altitude, it sends you an error that basically says your number for perigee isn't good. It's actually just fine. There's a simple trick to this. Do a drop down, go to semi-major axis, then do the drop down again and go back to apogee altitude, perigee altitude, and then just type the thing over again. Click apply. It stops giving you the error. Usually after you do it the first time, it will stop crying at you. So you kind of have to do it just once every time you're loading the stuff up. But if you do run into that problem, now you know how to work with it. I'm going to click OK. All right, so what I've done is I've actually now moved my satellite farther away from the Earth, and we can see that, interestingly enough, my circle on the 2D track has gotten a little bit different. Okay, now I want to see how that's actually helped me. Oh, I almost forgot. Hopefully you've seen some of the other videos along with it, but if you haven't, you can actually watch in real time. We can hit play. Well, it's not real time. I can speed it up or I could slow it down to real time, and then it'll be going very slowly, but I'm going to speed it up some. We saw it a moment ago. I'm going to speed it up a bit more. We're not getting any contacts here because the line isn't going through. Oop, there we go. I'm going to pause it here. Now on the 2D track, that circle that we see is actually anytime your orbit line goes through that circle, it's telling you that you have contact. That's what that circle was about. And it only shows up after you've set up the access because now it's showing us the access between ISAT and KPNO. At the same time, in the 3D view, we actually see a line connecting them. So these are clues after you've generated the access report. It won't show up beforehand, but after you've generated the access report, it'll actually give you a visual clue as to whether or not you're making contact. Okay, great. Now that we've shown some of that, I can always rewind the entire scenario by hitting the red button here. And as much as it can be worthwhile to actually watch the satellite go round, the big thing that we want now is, okay, I made some changes. What am I getting out of that? So I'm going to go back over to ISAT. I'm going to right-click, and I'm going to go to Access. I'm going to do my access report. And the number that I'm looking for is at the very bottom here. Hey, we're now a total contact time of 24.9 hours. So that brings us up to a score of almost 50. You'll also notice that instead of just the 89 access contacts, we actually had 92. So as we adjust these values, we can actually get more contacts, maybe even longer contact times. But most importantly, right now for this scenario, our goal is to try and get as big a value in hours as we are able to during this 2-week period. Now, unfortunately, the way orbits work, you won't actually be able to just get the satellite to sit on top of KPNO the entire time. It's actually got to continue spinning around the planet. In fact, that's important because otherwise it'd come crashing to the planet. Right now, it's actually falling forever, at least hopefully forever. All right, taking a look on this. My computer does it very quickly, but I'm going to bring this up real quick. I'm going to do ISAT. Let's make some adjustments here. I'm going to do an orbital inclination of maybe 35, and then I'm going to do an argument of perigee. Let's go with 270. I'm going to bring my perigee down to 500. I wouldn't recommend making this many changes in one move. You're supposed to not complain anymore. Making me look bad. Just go away and then come back. Should be good. All right. Ran, let's go ahead and make that, I don't know, 25. And true anomaly, 15. I'm going to click apply, but down here, you're actually going to see that there's going to be a red stop sign, even if it's just briefly, while STK actually goes through and crunches all of those numbers to update all of this and everything in the scenario. So I'm going to hit apply and watch down here on the bottom right. Apply. It only showed up for a short time and it had 0%. This is a decently fast computer. I'll go ahead and mention that. This is a gaming computer, so it's actually got a good amount of RAM, has a good video card, among other things. If you're using an older computer, it may pause for a little bit while it's calculating all that. And in the very complex scenarios, it's probably going to pause for a while. Try not to interrupt it. As much as you're in a hurry and want to do this as quick as you can, you might watch on the bottom right so that you can see, okay, as soon as the stop sign disappears, it should have done all the calculations and we can see what we've got. Okay, I made up some numbers, so hopefully I didn't just solve the entire scenario for you, but I guess we'll go ahead and double check since you could probably just put those in. Now, that's strange. I right-clicked and I clicked access, but the window didn't come up. I did a subtle thing. Instead of closing it last time, I minimized it. Look down here on the left. It says AC. That's actually my access window. I can click either the double windows or the big one to make it as big as possible. I'm going to click the double windows. Oh, there it is. Okay, great. You probably don't have to do this, but I'm going to click compute again because I made a change. And I'm going to click my access report. Now that I've got my new access report, I can go down and see what I've got. 24 hours, that's not bad. It's a little bit less than what we had just a moment ago. Man, I really wish I had written down what we had done just a moment ago. That would have been useful because that was a better solution. Check out our Sheets lesson that goes along with this as well, and we've got some recommendations on the easy ways to actually keep track of this. All right, we've looked at most of the stuff that we've got, but I'm going to give you a few more recommendations on here. Now, I don't actually need the access panel open the entire time, as long as I've got the access report. This is the one that I actually care about. And you know, the other thing that I need a lot, that would be nice if I didn't have to keep reopening it, is the orbital parameters. So now, here's what I've done. I've got all four of these windows open. I've got my 3D viewer, my 2D viewer, which may or may not prove useful for you. But I've also got my access report and I've got my orbital parameters. Those are definitely useful, at least for this scenario. If you come up here to window, we can actually tile these horizontally. And this is a nice trick that I and my cadets use to help keep things organized. It's now actually filled in the space. This works better on a computer that has a larger resolution, of course, but let's watch something here. So I'm going to adjust things so that we can see what's going on in the 3D view. I'm going to look from below. And here's what I'm going to do. I'm going to break the rules, and I'm going to go up to 2,500 kilometers for my apogee altitude. And I'm going to match my perigee along with that, so I'm going to make a circular orbit. I don't know why it's continuing to throw this error at me. Maybe there's something I need to update on my computer. I apologize. But it's a small inconvenience. We can see that our orbit got noticeably farther out. Now this one is me cheating, but now look at my report down here, my access report. Well, it still says 24. Well, that's because I updated the orbit up here, but I haven't updated the report down here. Now you might think, okay, well I need to close this and I need to reopen it, but that's what I want to show you. If you come up here, there's a page with little cycled arrows on it, and it says refresh. Click that. Instead of having to close this window and reopen it at another point, now you can make your adjustment up here in one window, see what it does in the other windows, and you can just click refresh on the report that you care about, and it will generate the new numbers and show you. We can see that this one actually gives me a really good outcome. I've got 49 hours. Why, that's almost a score of 100 right there. But unfortunately, this isn't a useful score because I'm way too high up. I'm not allowed to go higher than 1,500 kilometers with either my apogee or technically my perigee, but the perigee has to be lower or equal to the apogee, and the apogee cannot be lower than the perigee. That's actually the error that it's throwing at me. Okay, I wanted to show you this organizing window technique. This is one of the ways that you can really supercharge how quickly you're working through this. This allows you to actually try a bunch of things very quickly. But trying a bunch of things, well, you might change something and then it gets worse. So it helps to be able to have a good system for keeping track of what you're doing. Again, check out the Sheets lesson for the A series. Okay, we're running low on time, but one of the last things that I wanted to bring up on this, especially with our first scenario here, and we'll take a peek at the third scenario that I've actually opened up, and a little bit along with that. But one thing that I wanted to bring up is definitely your 2D and your 3D views. We can see the circle that got filled in, and again, that's weird that it's a half circle. There's actually something that I want to show you here. Watch something. If I go up to an inclination of 70 degrees, I'm going to click Apply. Now, in some of my other videos, we talk about what that means, but now my satellite goes noticeably higher. Hey, my half circle stopped being a half circle and is most of a circle, actually. The top part is cut off. One thing that you'll notice on this is the top of it seems to correspond with the highest point in my orbit. Something to think about. I'm still getting good contact times with my target, even though it's at a latitude of, let's find out, I can go to KPNO, go to its properties, and I can see that it's at a latitude of 31.95, about 32 degrees north. Now, one of the things that is a common thing that I've seen with new students is they'll usually set their orbital inclination to match the latitude of whatever their target is. But you can actually overshoot it depending on what your constraints are, how well it can see. And so I want to emphasize that. Here's a place where you can actually use information about the 2D graphic and the 3D graphic to actually get an idea of where and when you're getting good contacts, what walls you might hit. All right, one of the last things that I want to bring up is about that inclination. Well, for the most part, I could go to a much higher inclination and my satellite still be able to see my target for at least some of the time. Oh, I made a change. Let's see if this is any good. I'm going to click refresh. Ooh, nope. I mean, it's still good, but not as good as the last one. And that's something to take note of. We've got a bigger circle, but that didn't necessarily mean that we got better results. It's kind of a mix of these things. That's also why being able to design is very useful. Now, the more you play with this, the more you're going to get an actual in-depth feel for, I think I should actually lower my inclination some and maybe try and swing my orbit a little eastward. But I'm going to leave that to a future set of lessons or something that you learn as you go. Last thing I want to bring up is this. Now, the very first scenario in this has very little when it comes to limitations. KPNO has its information here, but that's actually a telescope, effectively, an observatory, set of observatories, on top of a mountain. So it has pretty clear line of sight through most of the sky, honestly. We're going to see in just a moment, I'm going to bring up constraints in some of the other scenarios. And those are ones that aren't on a mountaintop that the satellite can easily see. So finishing up our lesson today, you may not necessarily be adjusting these, but I want you to know why sometimes what works in the first scenario might have to be adapted for the second or third scenario. In the third scenario, we're looking at Meteor Crater, which is an impact crater in Arizona. I'm not going to zoom in way too much, but one thing that is interesting for Meteor Crater, in this particular scenario, we've got a camera that we're trying to take pictures with. So I'm going to go to Meteor Crater and bring it up. I've got the information for Meteor Crater itself, but I want to come down to constraints. Constraints is where we can put in limitations on when and where it can see certain things. In this case, because we want to be able to see the bottom of the crater, the minimum angle of elevation for our target, in other words, the satellite has to be at least 16 degrees above the quote-unquote horizon in order for this target to actually count time. That's a way that we could have it kind of take into account whether or not the satellite would be able to see the bottom, the center of Meteor Crater. Another thing that we brought up is this, that we wanted it to be pictures, so we need sunlight. Particularly, we're asking for direct sunlight, not umbra or penumbra. Definitely not umbra, but we want pictures where it's got direct sunlight, not when it's sunset or sunrise, for want of a better term. But these are some constraints that will affect what you solve in the first one, might be a bit different than what you solve in the last one. Also, for the satellite, it's a camera and it can only focus on things at specific ranges. So on this, I've got constraints where for the satellite, it can only see things as long as they're at least 200 kilometers away or farther, and the farthest away it can see is 2,000 kilometers. That's kind of like if you've got a pair of binoculars, if you put them in front of your eyes and look at a piece of paper on a desk, you're going to have a hard time actually reading it. That's kind of the minimum range one. And if stuff gets far enough, your binoculars might still not be able to be powerful enough to allow you to see it. You might need a more powerful telescope. That's kind of the idea on this, and it represents real-life optics in hopefully an approachable way. These are the key things that we wanted to introduce for our A series and to get across for you so that you can hit the ground running. Hopefully this video has been useful.